Lesson 2, solving polynomial functions by factoring. Harken back to our quickie unit 3 on factoring. This is where you've got to put together all that algebra 1 factoring and the new stuff that we learned. The sum and difference of cubes, as well as factoring things that are in quadratic form. Now, without further ado, remember that solving means that you set y equal to 0 and find the value or values of x. Okay, factoring notes repeated again. I'm not going to read through all this, but you do need to be able to do a greatest common factor and know that that's what you take out first. Then, if you only have two terms, and subtraction, is it a difference of squares? If it is, use the pattern. If only two terms, and it's not a difference of squares, is it a sum or difference of cubes? If it is, use the pattern. Use SOAP, same, opposite, always positive, and then the SMS. Now, if it's three terms or a trinomial, factor using the box method. Here I've got the box method. Okay, you can also use being a star. That means that you multiply A times C and put it here. You put B here, and then AX here, and AX here. Remember, it's x squared, but you're just doing AX. Now, what comes next? You've got to find two numbers, B1 and B2, such that B1 times B2 will equal AC, and B1 plus B2 will equal B. So you're looking at all the factors of AC, finding the ones that will add up to B. Now, once you do that, and you have to do that no matter what, whether you're putting it in the box or not, because notice there's B1, B2. And if you were to do it by grouping, you would have AX squared plus B1X plus B2X plus C, where you've just replaced BX with B1 plus B2. And then you would solve by grouping here. So either one. If you use the star, simplify each of these fractions, and then remember that it is bottoms up. Okay? Quickie review. Now, if there are four terms, you're going to factor by grouping. Greatest common factor again. Once you're all done factoring, this is all the factoring stuff. Now you're going to use the zero product rule. That means that you set each factor that contains a variable equal to 0. Okay, and you look for the roots, solutions, x-intercepts of that quadratic equation. You set each factor containing a variable to 0 and solve for the variable. If it is not factorable, use the quadratic formula. Check your solutions by either substituting them into the original equation and checking that a true statement results, or graph the original equation and check where the parabola crosses the x-axis. Remember, the x-intercept, roots, zeros, and solutions all mean the same thing. However, you also have to remember that you do know about imaginary solutions if you've got an x squared equals a negative. Now, moving on to some more. Zero product rule. If A and B are real numbers and A times B is equal to 0, then either A equals 0, B equals 0, or A equals B equals 0. Now, first thing we're going to look at is something that's not in quadratic form. X to the fourth minus 3x squared is equal to 4. We must write it in standard form. That means set the equation equal to 0. So you're going to subtract 4 from both sides. Now, you're going to factor this. It's not a quadratic, but it's in quadratic form. If you had to, you could also let A equal x squared. Then you would have a squared minus 3a minus 4 is equal to 0. When you factor that, you'll get a minus 4 and a plus 1 equals 0. A is equal to 4. Oops. to 4a equals negative 1. Then substitute back in. X squared is equal to 4. X squared is equal to negative 1. Then x is equal to plus or minus 2. X is equal to plus or minus I. This is if you need, okay, if you need to do the substitution. Otherwise, hopefully you've gotten to the point where with this type, you are very comfortable just doing x squared minus 4x squared plus 1. This one, you can either set x squared equal to 4 and remember that it's plus or minus 2, or you can factor it into a difference of squares. Okay? So notice, this one you could have factored multiple times, or you could have recognized, or you could have just used square roots. It really doesn't matter. Factoring at least has to happen here. Now, when we check it, here it's crossing at negative 2 and positive 2. Can I check the plus and minus I? No, but I can see that it's got two relative minimums and a maximum. So someplace in here, we've got our imaginary solutions. Solving polynomials using quadratic methods. This I'm not going to walk all the way through, just like I did the previous one. This simply has it set up so that you can let a equal x squared. Okay, so you're going to rewrite in terms of a. Oops. We're going to do this. Cut. I don't know what happened there. And paste. Okay, we're going to rewrite in terms of a. Sorry, I meant to do this. In terms of a, the x to the fourth minus 2x squared minus 8. Here it is. Factor it. Then you can replace the a at any point. You can replace the a with x at the end or here right after you've got it factored. Your choice. You do have to identify, okay, real solutions and imaginary solutions. Now, here's another example. Sum and difference of cubes. Rest assured, there's almost always a sum or difference of cubes on almost every test that has anything to do with factoring from here to the end of the year. You have to know this pattern. It is just a pattern. Please, 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 please. Memorize it. Same, opposite, always positive. SOAP tells you whether you're adding or subtracting each term. Other than that, it's the cube roots. Then it's squared, multiplied, squared. And again, you don't care about pluses and minuses because you use SOAP. So the 27x cubed plus 1, the cubic root is 3x, the cubic root of 1 is 1. Now, if I square 3x, I get 9x squared. If I multiply 3 times 1, I get 3x. If I square 1, I get 1. Squared, multiplied, squared. Same, opposite, always positive. Now, this one here, this linear factor, I'm going to use all of our math words. Our linear factor is easy. We set it equal to 0 and solve, and we've got a real solution. On the other hand, it should be noted that unless you have a greatest common factor that you did not take out, the quadratic that is left when you've got a sum or difference of cubes is not factorable. There are no factors of 9 that add up to negative 3. So you've got to use the quadratic formula. Here's quadratic formula, man, and here's the quadratic formula. The quadratic formula will appear on the SOL formula sheet, and thus you will always have it. If I forget to put it on a test, if you don't see it on the test, let me know. I will be happy to write it on the board. Hopefully by the time you use it enough, you kind of have it memorized. All right, so never fear, the quadratic formula is here. You simply have to make sure that you've written it in standard form so you can do your negative b plus or minus the square root of b squared minus 4ac all over 2a. Biggest places where students make mistakes, right here. They forget it's negative b. Put b inside a parenthesis so you can see if it's a negative and a negative. The other thing is right here. it doesn't matter if b is positive or negative. B squared is always going to be positive, okay? Always positive. So a lot of times I get students who just don't think about it and they plug things into the calculator, they don't use parentheses, and they do -3 quantity squared, like so in your calculator. Oops. I get students who do this. They'll do -3 squared, hit enter, and keep on going. That's not what you want. You wanted -3 times -3, which is +9. -3 squared is saying -1 times 3 times 3, which is how the calculator gets -9. Always put a negative number in parentheses when you go to square it. So, bottom line, after all that, you've got from your linear factor, and then you've got your other two. Now notice this was a cubic, and I have 1, 2, 3 answers. That's going to come in handy later. The degree will actually tell you how many solutions you should have if you include all your duplicate solutions and your imaginaries. Okay? Next one up. Let's look at another one of those. You combine two methods to solve this polynomial: factoring and zero product rule, as well as the quadratic formula. We have x cubed minus 1 equals 0. First, we factor. It's a difference of cubes. Then we solve the linear factor. Well, that was easy. That's where you hit the easy button. Okay? Hit that easy button. Okay, so there's our easy button. Bing, hit it. Solve linear factor using zero product rule. The thing that's a little bit harder is solving that quadratic. There are no factors of 1 that add up to 1. 1 just has the factors 1 and 1. That's going to be 2, or -2, or maybe 0. But it certainly is not going to be 1. So we plug in -b plus or minus square root of b squared minus 4ac, and we wind up with -1/2 plus I root 3 over 2, -1/2 minus I root 3 over 2. I don't care if you write it like this or -1/2 plus or minus I root 3 over 2. Either one is acceptable, okay? But you have your 1, 2, 3 answers. Okay, now it's your turn. Here's several of these to try, okay? And I've actually given you the graphs there so you can look at them and you can have a general idea of whether you're going to have imaginary or real solutions. But go ahead and try these. There's 4 of them on your paper, if you've got your notes, and then we'll check your answers. Pause the video. Bada bing, bada boom, you're back. Okay, this first one, can we factor it? Are there factors of +6 that will add up to +7? Of course there are. Oops, let's try being color coordinated, shall we? Okay, we know it's going to be x squared plus 6 times x squared plus 1. Okay, remember that 6 and 7, right? 6 times 1 is 6. 6 plus 1 is 7. This is all equal to 0. So that means that x squared is equal to -6, or x squared is equal to -1. X will have to be equal to plus or minus, got to take the square root, I square root of 6 plus or minus I. Did you get that? Notice it's a 4th degree. We have 1, 2, 3, 4 answers, and nothing actually touches or crosses the x-axis, so therefore we know they will all be imaginary. Okay, over here, I'm going to cross. It might not be in exactly nice places, but I'm going to cross. Let's see if we can factor this. Okay, I'm looking for factors of -10 that add up to -3. How about -5 and 2? And I don't have to do the whole star because a is 1. So I know it's just going to be x, or it's going to be whatever, minus 5 and whatever plus 2. So we're going to have x squared minus 5 and x squared plus 2. So x squared will be equal to 5 and x squared will be equal to negative 2. Over here, this is going to be an irrational number, real but irrational. X will be equal to plus or minus the square root of 5. Over here, x will be equal to plus or minus, since I got the negative, I got to take the I out, and then the 2 stays under the radical. Were you successful? I hope so. And if you look here, notice negative 2 point something and 2 point something. Okay, the square root of 5 is 2 point something, so you're in the right ballpark. And then you've got 2 imaginary. It's only crossing it in 2 places. Now, we get down to old x cubed plus 8. This is a sum of cubes. The cubic root of x cubed is x. The cubic root of 8 is 2. And if I use same, opposite, always positive, I know I'm going to add because that's an addition. The opposite of addition is subtraction, and then always positive is plus. Now that I have my cube roots, I'm going to square the first one, then I'm going to multiply them together, and then I'm going to square the second one. Now, I've got my linear factor. X plus 2 is equal to 0. X equals negative 2. Again, easy peasy. There are no factors of positive 4 that add to negative 2. So I'm going to do x equals negative b plus or minus the square root of b squared. Negative 2 times negative 2 is 4. Minus 4 times a, which is 1, times c, which is 4, all over 2 times a. X will be equal to a negative, and negative is a positive. I've got 4 minus 16 all over 2. This is going to be 2 plus or minus the square root of negative 12 over 2. You can't cancel these 2's yet because I don't have a 2 here. All terms have got to have a 2. Now, remember, simplest radical form. The square root of 12 is the same thing as square root of 4 times 3. Square root of 4 is 2. So I'll get 2 plus or minus 2 root 3 over 2. Oh, I can't forget my I here because I got the negative out. Now everybody cancels and you wind up with, you've got your negative 2 here, and then you've got 1 plus or minus I root 3. Okay? Last one up here. Factors of 18. Okay. I need factors of 18 that will add up to 11. Did you say 9 and 2? You are so smart. X squared plus 9, x squared plus 2. X squared equals negative 9, x squared equals negative 2, x equals plus or minus 3i, and then plus or minus I root 2. Notice, if you look at your graph, it does not cross the x-axis anywhere. Therefore, I know all 4 solutions will be imaginary. Okay? All right. So, moving on. In summary, polynomials of higher degree can be solved using quadratic methods. Factoring, zero product, square roots, and quadratic formula. You might use one or several to solve. Okay? Irrational and imaginary solutions always come in pairs. They always come in pairs because I got this plus minus. The plus minus the square root ensures 2 irrational or 2 imaginary solutions. Only real rational solutions can come as a single solution. And we're going to learn more about that later. Just the more times you hear it, the better it is. That's it. Most of this has been review, just putting together lots of things.